Continuing on with topic 1 on the heart, it says other important characteristics about the heart are, in general, arteries contain oxygenated blood. I guess actually. So oxygenated blood in general, when we're drawing diagrams, will be red, while veins contain deoxygenated blood, which we normally signify as blue. However, there are 2 exceptions. So the 2 exceptions are the pulmonary. So the pulmonary arteries, they actually carry deoxygenated blood, and the pulmonary veins carry oxygenated blood. So the reason why is because they are basically, the arteries are bringing the blood away from the heart to the vein or to the lungs to get oxygen. And then the pulmonary veins are bringing the blood back to the heart with oxygen to be pumped out to the body. So something to actually just remember instead of thinking like, oh, arteries are oxygenated, veins are deoxygenated, is this. So I always remember it this way, which is that arteries bring blood away from the heart. A for away, that's what I think of. And veins, they bring blood to the heart. So as long as you remember A for away, then it'll sort of link up. So that's why even though the pulmonary arteries, they are bringing blood away from the heart, that's the only ones that are going to be bringing it away where it doesn't have oxygen in it. So this whole thing about, oh, here's one exception, as long as you remember this, then you don't really need to worry about whether things are oxygenated or deoxygenated, okay? So here's a little video about the heart. You can also watch that. I can't play it inside of this video. This is explaining a pathway of the blood through the heart, and I already sort of drew that in the last diagram, but I'll read through this. So it says, once depleted of oxygen, so it's starting, exactly where we started. Once depleted of oxygen, blood returns to the right atrium of the heart through the superior and inferior vena cava. So that is right here. It's coming into the heart and then up there. All right. So it's coming into that spot where I put that X. The blood moves through the right atrium to the right ventricle, where it's then pumped out of the heart via the pulmonary arteries. So it follows this pathway up and out of the pulmonary. Okay, there's a pulmonary artery right here and right there, because we've got a lung on both sides. We've got a left and a right lung, so one tube goes to the left and one tube goes to the right. All right, so once it's gets oxygen at the lungs, that's where it'll take in oxygen and it'll give out the carbon dioxide that's in your blood, so it's exchanging it there. Then the oxygenated blood will travel back to the heart. So where is it going to travel back? It's going to travel through the pulmonary veins. Okay, so there's ones coming from both sides, both lungs, and it all gathers right where... Wow. I need to stop touching the side of this. So it all gathers right here, okay? So oxygenated blood travels back to the heart, where it enters the left atrium through the pulmonary veins. Then the final step is that blood flows into the left ventricle and is pumped out of the heart via the aorta, where it travels to the other areas of the body. So it's traveling through from the left atrium, through the left ventricle, up through this little valve here, and out of the aorta. And remember, the aorta can go at the bottom and at the top. So it's, if we looked at the back of the heart, there's a tube that's going to go sort of all the way down there. All right. So that's the pathway of the blood in the heart. So it's not too confusing once you know, like, oh, all of the right side of the heart is the deoxygenated and all the right side of the heart is oxygenated. Sorry, left side. There's a video here that shows the pathway of the blood through the body. You can watch that. I just can't play it in this video. So the beating of the heart, it says, although heart rate is mediated by the nervous system, the stimulus that triggers the heartbeat is located within the heart itself. So our nervous system, our head or our brain is going to tell our body to, you know, make its heart, the heart beat. But where and what decides sort of the stimulation of the heart is right in its heart, the heart itself. And how that heart beats is sort of a bunch of nerves that are inside the muscle of the heart. So how does the heart beat? Well, there's a sino-arterial node, which I'm going to put a little X on right there. That generates an electrical impulse and it sends it out. See those little like black arrows that come from that? So it sends that message to all of that area. Then the atriums, which are this part and this part, those are going to contract. And once they contract, this signals the atrioventricle node. So that is this one right inside of the atrium. And it transmits the message through something called the bundle of His. So that is this long sort of nerve that's sort of connected there. So once the atriums contract, then it sends that message through the nerve that's sort of like throughout the body of the heart. And it transmits that message to the Purkinje fibers, which are right at the bottom here, and which leads to the ventricles to contract as well. So then those contract, okay? So the original part that's going to stimulate the heart is right here. Once that stimulates the heart, the atriums contract. So these parts, they contract. And then they send a message to this guy, which is the AV node. The AV node sends a message all the way down to here. And then the ventricles will contract. Okay? So that's how that all works. So it's basically a pathway of nerves that make your heart beat. And the real thing to remember here is that the SA node is the part that is going to start the heartbeat, and then everything else is sort of connected from there. Another video you can watch, but sometimes people have troubles or there might be some sort of problem with one of the nerves in the heart, and to be able to fix that, we can use something called a defibrillator, but also we can use a defibrillator is something that you would use in like a first aid situation where you might need to give someone a shock to their heart to get the nervous system or those nerves to start firing again. But some people that have continually problems with that, they would get something called a pacemaker. And the pacemaker is basically just wires instead of the nerves stimulating that part of your heart so your heart continues to beat. Okay? And you can watch the video here to sort of show what the pacemaker does. But generally, it's going to be stimulating the SA node. And then that SA node can send the message to the rest of the heart. But sometimes people have problems, or there might have nerve damage in other parts of it. So the pacemaker can be targeted at those different nerves. And then the last section here on the heart is about ECGs. And these are called electrocardiograms, and they can be used to record your electrical activity of your heart. So if we want to see if your heart is, beating properly, we can look at your ECG. And when we get back into class, I have an ECG machine that we can test our own heart rates with the calculators we have in class to see sort of what your ECG, readout would look like. But how do we read this? Well, basically how this works is that the P on this, which is right here, is the contraction of your atria. So there's like a little bit of a nerve impulse to make your atrium contract, okay? The QRS is this big, huge sort of peak in the graph. And the QRS wave is basically the contraction of your ventricles. So that's what mostly is, most of the action in your heart is your ventricles contracting. Because those are the things that are going to have the most pressure. They're going to be pushing the blood out of your heart, whether it be to your lungs or be to the rest of your body, but that's where most of the energy or the nerve impulse needs to go to. So that's why that part of the echocardiogram is such a big wave. Okay, so this one is that. QRS is the red. And then our T is our recovery. So everything, it sort of has a little bit of a recovery time. And that's just because everything can't just be constantly contracting. And you'll notice that when we learn about nerves in Bio 30 is that there has to be some sort of like rest time. So the T wave is just it like, readjusting and being ready for the next time that it has to contract. Okay, so this is what you should typically see when we test our heart rate. And I think every time we've done this in class, everyone's had a normal heart rhythm. But if it's not normal, then that's something I guess that you should see a doctor about, but I'm sure your guys' will be fine. It says because the ventricle recovery occurs at the same time as the atrial recovery of the heart cannot be detected, or the atria. So basically, the recovery of the ventricles is happening at the same time as the atria. Oops. So the atria is recovering there too. I don't know why we didn't just write that. Okay, so this is what a normal ECG would look like. This is what ours should hopefully look like when we go into class. What would happen with a heart rate that would look sort of like this? This is called a myocardial infarction, and that's basically you're having a heart attack. So your heart rate is not, the ventricles aren't pumping out properly because we need this sort of curve to be, and this is not okay. So this is a myocardial infarction is a heart attack. So if you're having a heart attack and we did an ECG, you might see a heart rate that looks something like that. What would an ECG of a person who's exercising look like? Well, generally it should look normal, right? The only thing that it might be happening is that it might be happening faster. So maybe just the rate of it, if we were looking at the time limit between here and here, might be, I guess the wave sort of starts there and ends here. So if we're looking at one of those, we might see that this is a shorter amount of time if you are exercising versus not. Okay. That is the whole heart section. That brings us to topic 2. So I will do this video today, and then I'll post your topic 2 video tomorrow. So you can work on topic 1 today, and if you've got your package, but just keep working and make sure that you can finish at least the first 3 topics before you come back to school. Also, I'll be in school next week, Tuesday to Friday, so you can come in and we can do this in person if you would like. All right, but if not, continue working at home and let me know if you have any questions.